Yeah. Did you get VA and VB?
Oh yeah, got it.
So like this you have to do. If it's a two-dimension collision, okay. First conservation along x direction, then conservation along y direction. Okay. So this is the
Alright.
next doubt, है ना? So in this, what is your doubt? This is your doubt. Hmm.
My doubt is I did not understand the graph properly.
Hmm.
And I got the EMF by fluke.
Hmm.
I did not understand some, but I got the first one right somehow. Then I got the yeah. Can you solve the second one and the third one? And also, can you explain me how the first one is 2.4?
This is the figure, na, I think.
Yeah, that's the one.
Battery EMF, internal resistance, variable resistor. Okay. Ammeter measure current I in the voltmeter. Okay. Okay. So this is the circuit given to you. EMF is the internal resistance small r. There is a ammeter to measure the current. There is a voltmeter, and this is the rheostat we call. Okay. That is the variable resistor. Okay. So what is happening? Yeah. And then this kind of a graph is given between V and I. Okay. So this V is the voltage and this is the current. Okay. So this is decreasing with the
So
time.
if you go up, you can read the question too. Like there is more up. Yeah.
Resistance R is now varied to change value of I and V. Variation of I and V is given to you. Okay. Okay. So what is happening? We are varying the R. Okay. This rheostat we are varying. Okay. So what will happen? Say suppose if I increase this R. Okay. If I increase the R, then what will happen? We have here. We know that V is equal to what? E minus IR. We know this relation. And this V that appears across this rheostatic variable resistor, that is the same V that is appearing here. Okay. So from Ohm's law, I can write down as V is what? I into R. So this will be I into R. Okay. I into R. So that is equal to E minus I. Suppose capital I are right here, and here also capital I are right here, into small r. Okay. So from here, I can rearrange. I can take this to the left hand side. So it will be IR plus IR, okay, equal to E. Okay. So I can take out I as a common from here. I can take out a common here. So I will be equal to E by R plus R. Okay. So see here, this EMF is a constant. EMF is a constant. This is internal resistance is also constant. So only the R is the variable. So if I increase the R, you can expect what will happen? I is going to decrease. Okay. I is going to decrease. Okay.
Yes, sir.
So how is internal resistance constant? Won't it change? Like if variable resistance increases, then R will decrease, right?
Internal resistance depends on the battery, what type of a battery you are taking something, say. So it has to do with its internal structure. So it's a constant. Okay. So if R increases, then the denominator increases and the I decreases. Okay. So then what will happen to the V here? We have V equal to E minus IR. Okay. So what is happening? E is constant, a small r is constant, this I has decreased, if r has increased. Okay. So what will happen? This term will decrease, which we are subtracting from E. So what will happen? The voltage is going to increase, isn't it? The voltage is going to increase. Are you getting this?
Yeah.
Dasha, are you getting this?
Yeah, one second, sir.
So, but then,
So
or you can go ahead. Flash, you can go ahead.
no, but just so basically the resistance will increase.
Resistance increases, so the current will decrease. है ना?
Okay, so it's inversely,
And then
yeah.
from the first equation, we have the voltage. है ना? Voltage is E minus IR. So E is
Yeah.
constant, small r is constant, this I has decreased. So small I into R, this product will decrease. Okay. And then that is
Yeah.
getting subtracted from E. So what will happen? This term V will increase now.
Oh,
And
so
then
it increase.
lesser,
Okay, yeah.
lesser term is getting subtracted. It's like 8 minus 5. How much? 3. Now if it is 8 minus 4, it is how much? 4. So this term has decreased. So this voltage that is going to increase. That is appearing across this, that is appearing in this voltmeter or across this variable resistor. Okay. Or that is this is the same voltage across this battery that is coming. Okay. So what they are asking, so this is the graph given to you. Okay, so you can see here. Okay, so this is the graph given to you. Okay, so you can now understand this graph from this and from the explanation that if I decreases, V will increase. Okay, I decreases, V will increase. So see, if I go from right to the left, I decreases. Okay, from 6 4 2 1 0. Okay, I is decreasing, then what is happening? The V is increasing. That is why the graph is like this. Okay, that is why the graph is like this. So they are asking us the EMF of the battery. So EMF of the battery, this will happen when this term vanishes to 0. है ना? When this term becomes 0, then only V will be equal to E. Getting the thing? So when this thing is going to happen, when the value of I will be 0. Okay. So in the graph, when the value of I is 0, so when the value of
So
I
that's
is
why it's
0,
with the
that is why
y-intercept.
the V is equal to E at that point. Okay. So when I is 0,
Right.
then it is getting, so from the, you can find it, it's 2.4. Now determine power dissipated in the variable resistor when there is a current of 5 ampere. Okay. Power dissipated. So that means they are asking V into I. Okay. So they are asking instantaneous power or what? I don't know. Let's see. Suppose it is instantaneous power, because time they have not given. Okay, time is not there, है ना? Time anyways. So I think that is instantaneous power they are asking. Power is equal to V into I. So V, when I is equal to 5, है ना? So you can find it out from the graph.
You
Okay.
just right,
So when
basically.
this
Yeah.
is 5, okay. So you have to draw another line where it cuts the x. Wherever it cuts, that value of V you can take. Okay. Okay.
1.3.
And if you multiply
V
it
is
with the
1.3.
V is coming
So
1.3. 1.3 multiplied by the 5. How much you are getting? 6.5. So 6.5, since it's a power, so units will be in watts. So 6.5 watts will be the answer. Okay. So this is incorrect. What you have done is also incorrect. Okay. Now
Yeah.
another part they are asking us, state what is represented by the value of gradient of the graph. So what do you think? Gradient of the graph represents what?
resistance.
See here. Okay. So this is the equation given to us. So I have been given a graph V versus V versus I graph is given to us. Okay. So what is the relation? See, let us check. I have the equation here. This is the second equation. Okay, this is the first equation. So this is the equation, and V equal to E minus IR. So I can compare it with the equation of the straight line. Okay, that is y is equal to mx plus c. Y equal to mx plus c. So if you compare it, the voltage is represented by the y, is the variable. Okay, and the x is represented by the current, that is the variable. Okay, and then this M is represented by what? That is minus R, that is the internal resistance. So that's what they're asking, what does the gradient represent? So the gradient represents
Oh, that's why it's internal
internal
resistance.
resistance represents, and the C intercept, it represents the EMF of the battery. Okay, so the slope M, it represents the small r, that is the internal resistance. Okay, so like this you have to solve such questions if it comes. It's a good question. Have you understood, both of you?
Yes, sir. Got it.
Yeah.
Okay. Now let us move to the next problem. Next problem is this one. I'll be sending all these notes, okay, and I will upload it in the YouTube, and I will share the link of the videos. You can again go back, and if anything, any explanation you want more, and again if you can. Okay.
Yes, sir.
Okay.
So just beware. You're actually showing the textbook, right? In the videos.
I'm showing the
So you
text.
might get I mean, our textbook is actually copyrighted. So
Okay.
if you get too many views, someone might, Cambridge will realize you're using their material in your videos, and they might copy it. Right?
Yes, sir. Don't upload this.
Don't upload.
No, I'm fine with it now. I'll be able to use it
I think
afterwards.
so. Just send
Copyright
it to
issue
us.
can happen. Huh?
Oh, you
Okay.
can just make it private link, right?
I make it as a private.
I mean, yeah.
Make private video.
There's an option
And
to
then
make it unlisted.
Okay.
so if
You'll
you
see the
make a
option.
private video, only the people who have the link can see the video. So then you can send the video to like particular people.
Yeah.
So then how will other students benefit? Suppose some other AS student is there, he can also see that video.
So that
So you can
other
send them the link.
Anybody can view in any video in the YouTube if the link it is public. Anyways,
But
let's
never
see.
mind. And never, no one really watches the videos. So it's a lot.
You don't watch the video.
No, I do watch the videos. I'm talking about you don't get many views.
That doesn't matter. Okay, so see here, two identical filament lamps are connected in series. Okay, and then in parallel to a battery of electromotive force 12 volts and negligible internal resistance. Okay, so what is happening? IV characteristics for each lamp is shown. So IV characteristics is something like this. Okay. Hmm. Hmm. So if I take if I find out the gradient of this, what it will give? It will give me I upon V, that is inverse of the resistance. And if you see that inverse of the resistance is what? It is decreasing with the time, isn't it? It is it is decreasing. So I upon V, that is decreasing. That means the opposite of this, that means V upon I, that will increase. That means the resistance is going to increase. Okay, the resistance is going to increase. Are you getting this? This is the I
Wait,
versus,
what?
this is the I
Yeah,
versus V
yeah.
graph.
Understood.
I versus V graph. This is, so gradient will be I by V. That is nothing but 1 upon the resistance. So if you see the
Yep.
slope of it, slope is what is happening. It is decreasing with the time, kind of. You can see that slope somewhere here is like this. Okay, Here the slope is like some
So my doubt is not actually exactly this. Can you go through the question for a second? I'll
resistance
tell
is
you what
kind
my
of,
doubt exactly is.
all the things are related. Okay.
But then you need to know what I want to know,
Use the
right?
information shown in figure 6.2 to determine the current to the battery in the circuit. Figure 6a.
Yeah, so yeah, my question was actually the second part and the second part of the second part. Like the second, yeah,
Second
you
part.
get it.
Ah.
Yeah, that's like I don't get how the resistance is 1.5, like the total resistance.
Calculate the total resistance circuit. So 1.5 you're not understanding how you are getting.
I got 0.75. How is it 1.5?
Both
I
the parts.
understood why I got what?
This one is also incorrect. This one.
Yeah, I understood why I got that incorrect because I got that, but then why did I get the second one wrong?
How much it is coming? 4.2 ohms. Huh?
You graph to find these out, right?
Yeah, we used the graph to find the values. I understood why I got, so I took wrong value. I took, the current is supposed to be 2.8 in figure 6.8, but I took 4. So that's why I got it wrong. I should have taken 2.8 as the current.
Can you go back to the graph 1 second?
Yeah. Yes, please go back.
So this you don't have the doubt, huh?
I do have, yeah, not in the figure 6.1a, but I have doubt in the how to calculate the total resistance in the 6.1b. Yeah, that one.
Let me read the question. Huh? So it's a 12-volt battery. Huh? Okay. So from the graph, just you can read and you can find out. But just wait. See in the series, okay, resistance is the highest, and in parallel, what will happen? Like suppose its resistance is R. Okay, its resistance is R. So in the series, total resistance will be 2R. It will get added up. Okay. And in the second case, this is resistance R, this is resistance R. So kind of in the parallel, what will happen? It will get reduced. It will become kind of R by 2. Okay. So all these questions are related. So 6 point, I'm doing the first one. Let me see.
So what are you doing? I'm kind of lost you.
So from the graph you can find out, है ना? 12 volt.
Yeah.
The current is coming as some 2.8 something, है ना? Current.
Yeah.
2 point.
So can you go back to the question 1 second?
Okay, see just here. I will discuss this whole question. So this is 12 volts here. Okay, this is the resistance R. This is the resistance R. So what happens? The potential gets divided. So it will be 6 volt coming in this, 6 volt coming across this one. All right. And then
Yeah.
in case
And
of
then we use the graph.
parallel, what will happen? Same voltage will appear here. 12 volt will come
Both
up
will
here.
have 12 volts.
12 volts will come up here, across here, and 12 volts will come across here. Okay. So the first part they are asking is circuit 6A, find out the current. है ना? So 6A current will be, I will take the 6 volts. So corresponding to 6 volt, okay, whatever is the current we will get, find out. So what is the current? Current is something like this. Something like this. So 2.8 amperes you are getting. Okay. Next, for the circuit in the B part. Okay, in the B part. Okay. So in the B part, see, for 12 volt, then I will find out what is the current. Okay. For the 12 volts, I will find out the current. So 12 volts, sorry, the current is 4 volts, sorry, 4 amperes. Okay. So that is across each lamp. So across each, this is also 4 amperes and this is also 4 amperes. So the total current across both, we will add it. Okay. That's why it is coming as 8 amperes. Okay.
Oh, right.
Because I have to
So
find out current through the battery, I have to find out. Okay. So ultimately it is getting added up. Huh? Current flowing through this one and this one, it is going back to the battery. Okay. So it is 4 plus 4.
Yeah.
It is 8. That's why it is coming 8. Huh? Next, calculate total resistance in circuit of figure 6.1a. So resistance will be V upon I. है ना? So V is total resistance I have to find out. है ना? यार गया. Total resistance I have to find out. So we can find it out. We know the current here. Okay, see here. We know the voltage and we know the current. 6 volt divided by the current is 2.8. Okay. So I'm getting the resistance across this. And I'm using V equal to IR. So R is equal to V by I. So voltage across first is 6 volt divided by the current. Okay. So 6 by 2.8 plus 6 by 2.8 you will do. Okay. So it will be like 2 into 6 by 2.8. All right. So it will be 12 divided by 6.8. All right. So 12 divided by 6.8 is how much? 12 divided by
4.2.
Divided by 6.8. So that is coming as
Oh, wait, sorry. Yeah.
12 divided by 2.8. है ना? That is 4.28. है ना? Or 4.3 you can write.
what? So 12 divided by 6.8.
Sorry,
Wait,
2.8.
why?
This is
So,
2.8. है ना?
yeah.
This is 2.8.
4.8. Okay. Yeah, that's 4.28.
Okay, so that is
4.3.
4.3 something we will get, and this much ohm we will get. Okay, so that's what he is getting in the second part. Okay, 4.2. Okay, now for the circuit 6B, again I have to find out the resistance. Okay, total resistance I have to find it out. So again I will find out the resistance. Okay, because the resistance will change. Okay, this is not a constant resistor, the filament. Okay, so here for the first one it will be 12 divided by the current. Current is how much? 4, isn't it? So I am getting how much? 3 ohms. Okay, so this is 3 ohms and this is 3 ohms and they are in the parallel. Okay, so 3 ohms and 3 ohms, two resistors in parallel. If you find out the resistance like 1 by R, then equal to 1 by R1 plus 1 by R2, it will be 1 by 3 plus 1 by 3, and then you take the reciprocal. This is 2 by 3, and then when you take the reciprocal, it will become 1.5. Okay, so that is why the resistance is coming as 1.5 ohms. Is it okay?
So wait, what?
They are in the parallel.
3.
They are in the parallel. Huh? So
12 by 4.
okay. So
Oh, it's 12 by 4.
So
No,
All
it is
right.
3 ohm each resistance. So 1 by 3 plus 1 by 3, that 2 by 3, and take reciprocal of it. So you will get
Right.
1.
Yeah.
Okay. So that's
All
why
right. That makes.
they are giving the answer as 1.5.
I took
So
12 by 8. That's why. All right. No, I understood.
So some mistake you have done. Okay.
So it's
okay,
12
so
by.
reciprocal and it gets okay, got it.
Okay. So now another doubt. Yes.
This is another part.
Another question is, so what you have to find out here? Magnitude of the force on the pin on the disc. Force you have to find out. Okay. So this is a question based on the torque. Okay. Question based on the torque.
Yeah. I don't.
So
Six.
let me find it out. Force on the pin you have to find out. Okay. So what is the question? Let me read it. Thin disc is the radius are supported at the center by the pin. Okay. Uh, the disc is vertical. Okay. Three forces are acting on it. Okay. 6 Newton, 1.2 Newton, and 1.2 Newton, like this. Okay. So what is happening? Two horizontal and
What
opposite.
will cause the torque in it?
Hmm.
The resultant torque.
A force of 6 Newton at an angle theta. The disk has negligible weight and is in equilibrium. Okay. So what will happen in equilibrium? Net torque will be 0. Okay. And net force will also be 0. Okay. So net force also you have to make it as 0. Okay. So here, what they are asking here? Force, na? They are just asking the force. Huh? So see here, you don't have to do anything. Okay. So this force and this force will cancel out each other. Okay. This force, uh, this force, and this force, they are equal and opposite. They will cancel out each other. So the only left force that is left here, okay, that is 6 newtons. Okay. So this pill will experience the force that is 6 newtons only. Okay. So this pin will experience a force of 6 newtons. That's it. Okay.
So sine theta of anything.
Nothing. Okay. Okay.
If that force acts at any point on the disk,
Hmm.
like if it's 6 newtons somewhere else, then it will still be 6 newtons.
It's an equilibrium, Hardik. So
Yeah, but
won't
then look at it has an angle. The direction of the
yeah.
force, the 6 Newton force, it's not exactly like at the center.
But see, I think that will not make any difference, okay? Because if I take the component along this, okay, and take the component along this, okay, so same force is going to act here also, okay, kind of.
But then that, yeah, but then, sir, the downward force will produce a rotation, right? Like it will not pull it. That one will produce a rotation,
Okay.
the one
So
which
see,
goes down.
this force that is acting left, same force will act here, है ना? If it has to withstand, okay. Similarly, the same amount of force, yeah. Some theta have they given, theta angle?
Wait, I'll send you the, just a second. Yeah.
See, this is acting on the disk as a whole, okay. So you don't have to think much about this force. These two forces are cancelling out, okay.
Yeah.
And this is the only force that is acting, okay. So that much force only will be experienced by the pin, okay. Don't have to think much on this. So 6 Newton is correct.
Yeah.
Even if you resolve, I think that will not help much. Okay. Now this is the last question. Last question, let us quickly finish it and then you can take a break and you can revise.
There's,
It's the same question you have sent.
it's not the same questions, it's a different paper. Yeah, it's same question but different paper. So what the, yeah, how I'd never understood this question. I always got this one.
You mug it
How
up
does
and
it
write
work?
down. If this question come, mug it up and write down 180 degrees. Because I also
But then
don't
how?
understand how it is coming, okay. Okay. So see here what is given, point x and y.
So right, I just have one last thing I want you to do. Can you just try to find answer to this? Like how?
So see, this is
This
going
is
up,
like the only thing remaining.
going down, and this is going up. Okay, so that is why they are giving 180 degrees something. Okay, that is you can think of. Okay, because nothing is given.
All right, so
Okay,
got it. I'll mark off the thing.
that is why it is 180 degrees.
Understood, sir.
Okay, so that's it for now. Take care, all of you. Any doubts, anything, you send it to me. Okay, I will try. Okay, most probably the exam is 9 to 10:15. So sleep early and rise early in the morning and try to come early to the school. Okay, I will also try to be there in case any doubt is there. Okay, I will be there. Okay, because
Yes.
subject teacher is not allowed to be the invigilator. Okay, so
Sir.
So at least too
Kanchan
late to
madam
say
is
that
your
after chemistry
invigilator.
exam.
Kanchan madam
So
is
you
your,
don't know chemistry, sir, just casually roams around the class when an exam is
yeah,
going on.
he have some of
So
the
it's there.
students also. But he is the
So
examination officer, na? He can, if somebody asks what are you doing here, so he can say that I am checking something. But I am physics teacher. I cannot be in the physics exam hall. Okay, it's something like
Yeah.
that.
So at what time will you be coming then? Will you be
Anyways,
coming early?
I will also try to come. Okay, so 8:30
So
something.
because the 8:30, that's like half an hour before the exam starts.
Yeah.
So I'm supposed to come at 8. Can you just come to school at 8?
So we
I'll
will,
also be there. Hardik will also be there.
so what
Yeah,
will you do
I'll
in?
come by 8.
Okay, I will,
So
I will,
for
I
how
will
many?
come by. I will come at 8. Okay, good, good. ठीक है?
Yeah, thank
Uh,
you, sir.
चलो, take care all of you. I'm ending the meeting. Take care. Bye. Best of luck for
Bye.
the
Yeah,
exam.
boss.
Bye,
Take care.
Hardik.
Thank
All
you,
the
sir.
best.
Take care.
Bye. Bye, Lasha. Best. Bye.
चलो.